Alright, so y'all go ahead and do the factoring and the math knowledge question, pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to have x minus 17 times x plus 3. For the math knowledge question, you're going to start with your formula that they give you, and they want to know the height. They tell you the volume is 270 pi, and they tell you your radius is 3. So you just have to solve for your h. So 3 squared is 9, so over on the right side you have 9 pi times h. So just divide by 9 pi, and your pi's will cancel, and then 270 divided by 9 is 30. So that would give you your answer. We're looking at lesson 17 today. We're looking at infinity as a limit and undefined limits. So hopefully after this lesson you'll understand infinity as a limit and undefined limits. You have to remember that infinity is not a real number. A real number you can put on a number line. Infinity we cannot make on a number line. If I put 0 here, and then this is 1 million, and then this is a quadrillion, and then this is whatever, you cannot put infinity here. That does not work. So it's not a real number, it's just a concept. That's something that you have to get. It takes a little bit for some people to get that, but infinity is not a number, it's just a concept. So for your limits, if you look at the graph of 1 over x, and they plug it in for you, 1 over x, as you get closer and closer to 0, when you plug in 0.1, you get 10. As you plug in 0.0001, you get 10,000. As you get closer and closer to 0 from the right, it's going to get closer and closer to infinity, because this number is going to keep getting bigger. And then from the left, it's going to be the same thing, it's just going to be going to negative infinity. The graph of this (1 over x) looks like this. And so from the right, as you approach 0, you're going up to infinity, and as you approach negative, you approach 0 from the left, you're going to negative infinity. So that's how you can have infinity as a limit. So for this one, we want to know not as it approaches 0, but as it approaches infinity here. That's a little infinity. Kind of looks like a sideways 8. So the way that you're going to deal with these, whatever is the exponent in your denominator that's the largest. So on that one, that's x squared here. You're going to divide every term in your function by that x squared. So we're going to say 4x squared divided by x squared. We're going to say x divided by x squared, and 6 divided by x squared, all over 3 divided by x squared, and 1 divided by x squared. And then we're going to simplify it. So these x squareds are going to cancel and leave that as just a 4. On this next one of the x's will cancel, so we'll have 1 over x. And then on the last one, none of them cancel, so we have 6 over x squared still. On this next term, these x squareds cancel, so we just have 3. And then nothing simplifies on the next one, so we just have 1 over x squared. So as x is approaching infinity, if we plugged in infinity here, 1 over infinity is going to approach 0. It doesn't equal 0, but if you think of 1 over 10, you have 0.1. If you think of 1 over a billion, it's going to be 0.00001. And as you get closer and closer to infinity, it's going to get closer and closer to 0. So this is going to 0. x squared, if you plugged in infinity, that would still be going to 0. Same thing with this one. It's going to be going to 0. And so the only thing that you're left with is the 4 over 3. And so that would be your answer. Okay, let's look at another one. We are approaching negative infinity this time, but it's still the same concept. You look in your denominator and you divide every term by the largest exponent. So it's still an x squared. So we're going to do x cubed over x squared. We're going to do 6x over x squared. And we're going to do 8x squared over x squared. And 5x over x squared. So x cubed over x squared is x. This would become 6 over x. And then over 8 plus 5 over x. So that's how it simplifies. Now again, this is going to become 0, and this one's going to become 0. And so we're left with x over 8. So we have to keep the limit because that's not our answer yet, because we still have an x in the function right now. So we have x over 8. So if we plugged in infinity, what is an extremely big number divided by 8? Negative infinity divided by 8. Surprisingly, for some of you maybe, it's still going to be negative infinity, because you're starting with a really, really, really big number, and you're only dividing it by 8, which sounds kind of big, but it's really not. It's still going to be negative infinity. So that's your answer for that one. Okay, looking at another example, the limit as x approaches infinity. So again, our largest denominator exponent is x squared. So we're going to do the limit as x approaches infinity, 5x over x squared, 7 over x squared, 13x squared over x squared, 10x over x squared, and 2 over x squared. And then you simplify them. So this first one is going to be 5 over x, and then 7 over x squared. And then we're going to have 13 plus 10 over x plus 2 over x squared. So if it's got a number over infinity, again, that's going to be 0. That one would be 0. 10 over infinity would be 0. And 2 over infinity squared would be 0. And so we end up with 0 over 13, which is just 0. So there's your answer for that one. So that's how you can do infinity as your limits. Whenever it says x approaches infinity, that's what you can work with. If it says x approaches 2 or x approaches some number, you cannot use this method. It's only when x approaches infinity or negative infinity. Alright, so now we're going to look at two graphs real quick. They're very similar. They're both 1 over x minus 2, but one of them is 1 over x minus 2 squared. So if you look here, both the left and the right hand limits are both going up, and so they're both approaching infinity. And so the limit at 2 is going to be infinity because the left side and the right side are both approaching infinity. However, on this one, the left hand limit is going to negative infinity, and the right hand limit is going up to positive infinity. And since our left and right hand limits don't equal the same thing at 2, the limit is undefined. Does not exist. So that's where you could have an undefined limit. So we want to look at an example. We want to find the limit of negative 1 over x plus 3 squared as it approaches negative 3. So if you want to write it in math terms, it would be x approaches negative 3 of this function. So the first thing we want to do is graph it. so we're going to put -3 right here. And it is going to have an asymptote at -3. And then the graph of it is going to look like that. And it's going to be on the same, they're both going to be approaching -infinity on the left and the right hand sides. They approach -infinity. So this limit is going to equal -infinity. And so that would be your answer for that one. Okay, so that's all for this lesson. You do get to omit number 17 on your homework tonight. So make sure that you do the other 24 problems so that we can go over them tomorrow.